In the previous lesson, we learned how to use titration in acid and base reaction. Now today we are going to look at in terms of applying the same method in redox titration. Well, what we have here is we have 10 milliliter of commercial hydrogen peroxide, and this is further diluted. I mean, you add water to it, add pure water to it, okay? Add pure H2O until you get 40 milliliter in a flask. Now, the solution is titrated with 0.15 molarity of potassium permanganate. This permanganate here, that would be MnO4 minus. So this is where it is right here, okay? And this is where your H2O2 is going to be. Now, the reading of the burette at the start of titration, at the end of titration are given below. This, of course, is where we start. And how do we know? Because the reading is smaller, and as it gets used up, it's going to go down, so the values increase. So this is where it's going to end. And one thing when you read this burette is that you are reading downward, okay? Because this is where 0 is going to start. So be careful, we're reading downward. So if I were to read this reading right here, it would be right here, isn't it? So downward, this would be 2, and that would be 2.50. Remember, it's 2 decimal places, just like that right there. And down here, we're going from here. We don't know our values for here, but we know this is 15. So we go upward. This must be 14 somewhere right here. So therefore, this must be 14.0 at the end point. Okay? And that's how you read it. And what's the unit going to be? Of course, it's always in milliliter. And there you go. In order to understand how the color change in this titration, we need to look at the reaction that's involved in this case. First of all, this right here, it is in our burette, and it has a color pink, okay? And what's happening is that this pink color, when it is react with the hydrogen plus right here, it would make this right there. And the product is colorless. So as long as it's the presence of H plus, we're gonna make this permanganate into a colorless product. And where is this H plus coming from? And that H plus is coming from here, which is produced from the hydrogen peroxide. So let's summarize this. The hydrogen peroxide in the flask will produce H plus that will react with the permanganate as we drop down into the flask, and that would make the pink color into colorless until all the hydrogen peroxide has been used up, so that any more permanganate solution adding in will cause the whole entire solution in the flask to turn pink. And we consider that as the endpoint. The hydrogen peroxide produced H plus that reacted with addition of permanganate ions coming from here, okay? And what is that going to do is that it's going to turn the pink permanganate into colorless Mn2+, until all the hydrogen peroxide in this flask is used up, so that any further additional of permanganate solution will make the entire solution down in the flask will turn pink, because there isn't any more hydrogen peroxide left to make the H+. And that's the concept of this titration. So the first type of question that you will see for this type of problem is write a balance equation. Notice we had to balance out the electron. So that has 5 and this has 2. So we had to multiply this whole entire thing by 5 and this multiply this by 2. So in this case, that would give us a total of 16. This gives us a total of 2, and this gives us a total of 10, and this gives us a total of 2 right there, and this gives us a total of 8. Down here we have 5, and here we have 5 hydrogen peroxide. 5 times 2 gives us 10. Then we have 5 right here, and then 10 electron. And now we combine the two reactions together and just write it out. In this case, they have hydrogen here, 16 on the reactant side. It's going to cancel with that 10. So what we're going to have left is 6H+. What about the MnO4 minus? It doesn't cancel with anything else, so we have 2MnO4 minus. And then the 10 electron get canceled out with that 10 electron on the other side. So now we have 0 electron. Then going to the bottom reaction, we have 5 hydrogen peroxide. It doesn't get canceled with anything else, so we have 5H2O2. Okay, now let's go to the product side. Here we have 2Mn2+, so it doesn't get canceled with anything else, so it stay there. And then for the water, it doesn't cancel with anything else, so it's going to stay there as well. So we have 8 water as well. And lastly, we have oxygen. It doesn't get canceled with anything else, so we have 5O2. And that would be our balanced chemical equation. And then another type of question is that, what is the oxidation number for permanganese in permanganate ions? Now, this is somewhat hidden there, so we don't have to worry about it. Well, let's look at this. MnO4-, right? The rule for oxidation number for oxygen is -2. Since there are 4 of them, so that gives us a total of -8. And if we look at Mn plus -8 equal to -1, that Mn must be what? It has to be +7. So therefore, it has to be +7. And then we can also be asked, another question would be, which species is oxidized? And the word oxidized means what? Lose electron. So in this case, which one has electron on the product side? And we know right away it is H2O2, which is hydrogen peroxide. Isn't that easy? If we ask you which one is being reduced, which one gaining electron, that would be MnO4-. Isn't that easy? And then another type of question would be, initially the color of the solution in the flask is what? Well, in the flask, the color is colorless. Even though I use blue, it's just to represent as colorless. But once all the hydrogen peroxide has completely reacted, the solution turns to a faint pink. And that's how we know that all the hydrogen peroxide has been used up. This is also known as the end point of the titration, okay? At this point, there is no H2O2 left in the flask to reduce or react with the color permanganate, which is MnO4-. So any small amount of permanganate added after the endpoint is unreacted, and it's going to cause the solution in the flask to turn to faint pink. And that's the process of titration. Now let's use those information to determine how many moles of hydrogen peroxide are in the solution. Well, first of all, we need to realize that how is the number of moles of hydrogen peroxide related to this volume? We know that if we go back up here, how much of the permanganate solution is being used? Well, we're starting with 2.50, and all of a sudden we end with 14. So what we're going to have here is 14 minus 2.50. That gives us 11.50. So that's how much of the solution of MnO4-, okay, is being used. How is that related to the hydrogen peroxide? Well, that's pretty easy, because now we can relate that to this using our stoichiometry. So before we need to do that, we know that 11.5, again, always convert to liter. So we have 11.5, let's write this out, 11.5 milliliter of MnO4-, okay? Now let's convert this to liter. That would be 0.0115 liter of MnO4-, okay? Now, we know the molarity of that permanganate solution as well, which is 0.15. So now, if we know molarity and solution, we just multiply together. We have 1 liter of solution on the bottom and 0.15 moles of MnO4 on top. So now that cancel out will give us moles of NO4. But how is the moles of NO4 relate to hydrogen peroxide? Well, go back to the chemical equation. 2 moles of NO4 is 5 moles of hydrogen peroxide. So what we're going to have here is multiply by that ratio. We have 2 mole of MnO4, and that's coming directly from the balanced chemical equation, and equal to 5 moles of H2O2. And that's pretty much it. Now we plug this into a calculator. multiply everything on top, divide everything on the bottom. 0.0115 times 0.15 times 5 and divided by 2, which is on the bottom. So we have 0.00431, and that would go right here. 31 moles of H2O2 in the sample, in the flask. So this is in the flask, okay? Now, how many grams of H2O2 are in the sample? Well, that's pretty easy. You take this mole and convert it to mass and just multiply by the molar mass. So 0.00431 mole of H2O2. What is the molar mass of hydrogen peroxide? Well, look it up or just use your periodic table to solve it. And that turned out to be, what do we have? We have the molar mass of 34.02. So in this case, the moles were here. So we have 1 mole on the bottom of H2O2 and 34.02 grams of H2O2 on top. That cancel out. And this is equal to 0.147 grams of H2O2. And here's the most challenging question of all, is what is the mass percent of H2O2 are in the sample? Well, why is this problem so difficult? That's because we are given 10.00 milliliter of H2O2 solution. How is that related to mass? We really don't know, but we can make an assumption that this has a lot of water in it, because 3% of the whole entire solution is what? Hydrogen peroxide. And what is the density of water? It is 1 gram per milliliter. So we can assume that the solution has the density of 1 gram per milliliter. So we have 1 gram over 1 milliliter. And look what happened to the milliliter. It's going to cancel out. So we have ourselves 10 grams of H2O2. Now we have the total, right, in the sample versus the part. So what we're going to have here is, again, percentage is equal to part divided by total times 100. In this case, the solution weighed 10 grams, and in this 10 gram, we have 0.147 grams of hydrogen peroxide. 0.14 gram of H2O2 divided by 10.00 times 100, and this gives us, let's plug into a calculator. We have 1.47% of H2O2 in the sample.